Hi, today we are going to learn what is VPC, how to set up your Terraform project. So yeah, first we are going to set up our Terraform project. Let's go to our repo. I'm going to provide a links in the description, right? So don't worry about it. Just click on SSH clone. You just need to clone it, right? I'm going to just create one desktop project 01 git clone. Just type git clone. Before that you need to have git. Just check git. If you add git like git, you can check version as well. I had this. If you first go and try to install git, how do you going to install git? Just search install git on Windows. If you have Windows, I have Ubuntu, so I am going to install it on Ubuntu. That's a very basic. You can get started installing also. Package manager, sudo apt update. This is the way to install. I already installed it, so that's why I'm not going to waste time with it. Git clone. Make sure you have git, right? Just go. We had the project, right? I already developed this project. I'm just going to teach you now, right? That's already just install the file. If you want to open it in VS Code, just type code. So open the folder. This is the folder desktop. I'm going to open the cloud project 001, right? That's our folder. Yeah, I trust the folder. You need to find a terminal. Just go here, click on new terminal, right? Here's terminal. This is the extension that I'm using. It's a shortcut. So first going to the Terraform. Go inside the Terraform pwd. We are inside the cloud project. This is this one. Desktop के बाद में जो भी है जो अपना है cloud projects for 01 Terraform, right? Which AWS CLI. Yeah, I just cloned the repo from the GitHub. If we got stuck somewhere, that time I'm going to solve it. I'm going to solve that error. So let's go first understand the basics. So yeah, what is VPC? VPC stands for Virtual Private Cloud. So I am going to explain you some terminologies here. Your isolated slice of AWS cloud, you don't know anything about it, it's okay. Full control over IP addresses, subnet and routing. Essential security and organization. Essential for the security and organization. Subnets, public versus private subnet. There are two types of subnet majorly. It's called public. It's another is private. What is public? Public means anyone can access it. Private means some admin or selected people are able to access it. It's called as private. Smaller network within the VPC. This chronology, VPC, you don't know anything VPC, that's okay. VPC का छोटा भाई है subnet, right? So smaller network within the VPC called as subnet. So there are two types of subnet here, public and private. So public subnet, route internet gateway for ALB and bastion host. What is ALB? ALB stands for application load balancer, okay? Then it's private. No direct internet route in, right? Public, I already in layman language, what is public? Anyone can access it. What is private? Some selected people or the private people or the close circle are able to access it. That's called public and private. Forget about subnet here. Just remember public. Availability zones means sectors. So spreading subnet across the multiple sectors called as availability zone. Physical data center that's provide high availability. That's called subnet. Connecting to the internet, IGW. What is IGW? IGW stands for Internet Gateway. Internet Gate. Why we are using Internet Gateway here? Internet Gateway is functionality the front door allowing traffic between VPC. You don't know about VPC, that's okay. VPCs just take some kind of building. VPC to the internet. If anybody wants to access internet from your building, you need to have Internet Gateway. NAT is like local communication. If you want to talk with your mom, you don't need to call her, right? She's in the kitchen, right? You can call, hey mom, I want this, that's okay. Okay, that's called as local. That's happened with the help of NAT gateways. Route table is just like they help you to route better, right? Travel better. That's called a routing table. Concept is like roadside in your VPC, control where traffic use goes. Each subnet must be associated with one route table and need to separate table from private. That's okay. Public route table, anyone can access that route called public route table. Hey, now I am going to tell you one story. In that story, I am going to explain like whatever services I use now, like VPC, subnet, routing tables, associations with the routing tables, private, public. That story cover all the things. If you are able to remember that one story, you sort out. You know all things that I want to share with you required for this project, okay? First, what is VPC? VPC stands for Virtual Private Cloud, right? What is Virtual Private Cloud? Let's say you have this plot, land. The fencing of this land, this is the fencing of your land, right? This fencing is called VPC, okay? Why we call VPC as a fencing? Because whatever you are going to do inside this land, you are responsible for it. The same way in a virtual on the cloud, if anything happen inside a specific VPC, the all blame and loss goes toward that person who owned that VPC, right? It's just same like buying a land, right? If anything happened in your house, right, some legal battle or something else like very generalized, some fighting happen inside your house, you are responsible for that fight. So that's called VPC. VPC is just the borderline. Anything happen inside the VPC, it's your responsibility. Anything happen inside the fence, it's your responsibility, right? So that's a mota called VPC, virtual private cloud. There is huge data centers in the cloud, right? Your VPC is just small. You just own that small space in the whole cloud, right? That's called as VPC in short. Another one is subnets. Let's say you buy the land and you're planning now to build a home on it. So what is subnet? You just divided that land into 4 pieces. That means you create 4 parts of it, right? Each part is called as subnet, right? This is subnet 1, this is subnet 2, this is subnet 3, this is subnet 4, right? You created 4 subnet here. Let's say this is your front door. So anything happen inside your VPC, it's your responsibility. And if you make a parts of your VPC, it's called a subnet. The small part of your VPC is called a subnet. So you divided your subnets into 4 parts. So in subnet first, you say like I am going to build my community hall, right? Community hall. So it's called as front end. As simple as that. Anyone can access it. So community hall is not spacious. So I want to build another one. So you build another community hall on the ES2 in second part called as subnet 2. So it's a hall. Anyone can access it and anyone can come inside and ask for any helps, right? Over there. Anyone can knock it. Anyone can sit there. It's called as hall. We used to call this hall or community hall, right? In S3 you say, oh, people are disturbing me. I need my own space. You build a bedroom in S3. In another subnet, you have built your bedroom, right? In S3 you build your bedroom. So this is your like private. Let's say this is the public. This is a public part, and this whole both S1 and S2 is a public, S3 and S4 is a private, right? It's a private and it's a public, as simple as that, right? You build a bedroom so no one can access it. If you want to get inside the bedroom, first you need to come in a community hall. That's the only way. So you need special permission, right? Subnet. What is subnet? The small part, the parts of VPC is called as subnet. So there are 2 types of subnet: public subnet, private subnet. What is public subnet? Anyone can access it, like community hall. What is private subnet? Like bedroom or private spaces or locker, right? Special person with special permission are able to access. That's called as subnet. 2 types of subnet: public and private. So another one is route table. What is route table? Route table is deciding the route toward our house, right? Pathway toward our house. How can you reach from community hall to the bedroom? Are you able to reach or not? That's also decided by the route table, right? The very functionality of routing table is how traffic flows inside our VPC. Subnet to subnet, public subnet to private subnet, private to private, public to public subnet. That's mainly configured inside the route table. Then what is IGW? Internet gateway, right? So what's the functionality of IGW? To provide internet inside the VPC. As simple as that. Who is going to provide internet inside the VPC? It's called as IGW. Internet gateway is going to provide internet access inside the VPC. So yeah, that's simply called as IGW. Let's say you are in the hall, community hall. This is called as CH stand for community hall, right? And you want to access to the internet, or you want to access, here's a grocery store, you want to access it. What's the way to access the grocery store? You need some door here, right? So that gateway between your community hall to the grocery store is called as internet gateway. Who is going to provide internet inside your VPC? The guy called as IGW, stand for internet gateway. Internet gateway is responsible for providing internet inside your VPC. Now let's say if you want to communicate inside your home. Let's say this guy want to talk with this guy. This guy want to talk with this guy. Let's say this is the way. This guy want to talk with this guy, and this guy want to talk with this guy, and this guy also want to talk with this guy directly. So A wants to talk with B, B wants to talk with C, and A also want to talk with C, right? So how can you communicate inside your VPC? NAT guy is able to. NAT is just, remember, NAT is just like agent who is responsible for intercommunication. I'm going to explain one more thing now. It's so called as security group. This is your gate. This is your society gate or your farmhouse gate. Here is one person always standing. So a random person not able to get inside it, right? This is called as security guard. In a cloud we call as security group. He know the rules. कौन अंदर जाएगा और कौन अंदर नहीं जाएगा, या कोई अंदर नहीं जाएगा. So इसको कौन समझाएगा कि कौन अंदर जाएगा और कौन नहीं जाएगा? We, admin. Here's a checklist. A person came with name 80 is allowed inside the building. A person with a name 443 able to enter inside the building. A person with a name 8080 is not gonna enter inside the building. So he rejected it. He stay out of it, right? So what is 80 stand for? HTTP request. A person with the name 80 can enter. A person with the name 443 also can enter. A person with the name 8080 is not able to enter because we configured the rule, right? That's his job. It's called a security group. Simply securing the building. As simple as that. Now I am going to explain again PPT so you get a better understanding of it. What is VPC? Your small space inside a whole cloud called as VPC. VPC stands for Virtual Private Cloud. Full control over the IP address. IP address, that means subnets and routing. Whatever happens inside the VPC, it's your responsibility. Essential for security and organization. Fencing is mandatory for the securing your land, so-called your cloud environment. What is subnet? Let's say you buy the land, so-called VPC. Land is directly proportional to the VPC, right? If we divided this land into 4 parts, each part is called as subnet. Smaller network within a VPC. Smaller network. This is one network isolated from another one. This is another network. This is another network. This is another network. In technical, a small network inside VPC. VPC is a big network. It's a big fence, and small network inside VPC is called as subnet. There are 2 types of subnet. I already explained it. Public and private. Public, that means community hall. Private means bedroom. As simple as that. Route to the internet gateway for ALB and Bastion host. Forget about it. No direct internet routing. EC2 app and service. Now connecting to the internet gateway. Now you have LAN, you have subnet. Now it connected with the outer world. You don't want it to be isolated. That's why we are using IGW, Internet Gateway. The internet provider inside your VPC, it's called as IGW, Internet Gateway. It's a gateway of internet, as simple as that, right? A front door allowing traffic between VPC and the internet. Only one per the VPC. You can create multiple subnet inside the VPC, right? But you need only one IGW, Internet Gateway, for the whole VPC. NAT Gateway, if you want to talk between the subnets or inside the VPC, we use NAT Gateway. Allow instances in the private subnet to initiate connection out to the internet, download packages, call extra APIs, but event, what do you want to say? Why we are using NAT? Let's say this is your VPC, this is your public subnet, this is your private, you are sitting here. This is the line between public and private subnet. You are sitting here. Here anyone can come because it's a whole community, and anyone can in, anyone can go out. Inbound and outbound traffic both are routed. But here, what is here? Only selected person are able to reach this person. If you configure NAT with this person, he is able to access everything from the outside. But no one can access him. As simple as that. Let's say aave yahan pe baithe ho and you want to order something. You can order it. If you want to call this person, if he wants to call him, he can call him. But this person not call back him, right? हम NAT को अच्छे से समझेंगे यहाँ पे कि what is NAT? Let's say this is your house, this person, this is public and this is private. So what's NAT doing here? He has NAT access, like Brahmastra called as NAT. What NAT is doing here? So he can call anyone in the world. This guy, 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 anyone, anywhere in the world. But these guys don't have permission to call him. He has, like blue means he can access anyone. But these guys don't access him. He can take help from anyone, but no one can take help from him if he is NAT configured. What if he is IGW configured internet gateway? He can call this guy and ये इसको भी बुला सकता है, ये इसको भी बुला सकता है, right? Other way around also work. Friendship will maintain. If he has NAT, he can only give the order. No one can ask him why. So yeah, in short, what is the difference between NAT and IGW internet gateway? This person can call this way, and this person can call this person. It's called as IDW. Both can communicate with each other. What about the NAT? This is the boss. Red is in boss. Blue, these are the other person. So boss can call anyone because he has NAT. But these guys not call him back. That's the power of NAT. NAT can call anyone. Routing table decide how the flow works inside the VPC. It's a work of route table. Concept link sign in the VPC control where the traffic leaving a subnet goes. Each subnet must be associated with one route table. This one subnet, this is one subnet. Why each subnet must associate with the route table? If subnet is not associated with the route table, how route table knows? This is also included in the flow, right? Let's say you build a house. Guests come here in the community hall, then going to the kitchen, or the kitchen, or some security checks. Then he can come to the bedroom. Then bedroom may say he can go inside your locker room. So if route don't know this guy exists, this room exists, how can he able to navigate it? That's so simple, right? Each subnet at least associate with one route table. Public route table, in layman language, what is public route table? Anyone can access it or enter inside the room. That means if this is the community hall, it must be configured with public route table. So anyone can access it, right? Anyone can flow inside it. Just forget about this line. You know the concept, you're good to go. Private route table. Let's say this is your subnet, this is your community hall. It's configured in the public route, right? Public route table. This is another bedroom, 2 bedrooms, let's say, and it's a private route table. So if you want to come inside your private route table, then you need to pass first the public one, then only came inside the route table. Is NAT gateway. NAT is also specified with the public. It's a local communication. No one can external. This guy can talk with every other guy, but this guy is not able to talk with this guy, right? What is open? What is public? Anyone can access it, right? What is private? Selected people or limited people can only do that. So that's NAT is always a private, remember it, and it's always considered with the NAT. Private is always considered with NAT, and public is always considered with IGW, Internet Gateway. Associating route table, each and every subnet associated with at least one route table, because route table is a pathway designer. What's our flow, right? Today first we are going to build VPC, then we are going to build subnet, configured subnet VPC with external world, that means IGW. Then we want to talk subnet with each other, multiple subnets, right? NAT gateway, subnet, IGW, NAT gateway, internal communication. This is public, this is private. Then we are going to configure it with the route table. Got it? Why route table? Because each subnet associates with at least one route. Route table is a door, subnet is a room. So each room has at least one door. What is security group? This is our LAN, this is our coordinates, right? If anybody wants to came inside, first we need the security check, so no one can breach the security. For that, here at the external, very external part of it, we using security. Right here, this is the gate. Here, this is our security. This is the VPC, subnet, IGW, NAT and RT. Okay, chalo. Let's move to the practical. Already installed it. Let me check. Yeah, this is my Terraform version v1.11.14. If you don't have, you always need 2-3. This is the official website. Search Terraform node 1 to install. Just go here. You can see step-by-step guide here how to install it. If you have Windows, just go Windows. #com install. This is Windows. Try to install from the official website only, or follow some YouTube tutorials as simple as it. Then you also need to configure AWS CLI. Install on Ubuntu. I think I have it. I already configured it. So first step to start our Terraform, just create main.tf file. Inside the Terra, just go, make sure you are inside this folder. Here also, in terminal also. See, Terraform project 001, project cloud 001 Terraform, right? So I'm just going to create main.tf. If you're not able to find this logo, just go to the extension and you need to install this extension. #com Terraform, right? I already installed it. Basically, you get formatting. Right? It's really helpful. So what is first step? Type Terraform, because now here we are going to configure it. How I find it? That's a good question. First, just go to the Terraform. This is the link. Terraform #com AWS.latest. If you have GCP, type GCP. You will find the docs anywhere. AWS provider. Example. What he did, he just for later we had latest, right? Show you the Terraform version of mine. 1.11.4, right? So it doesn't matter, just copy it. This is our main. This is main, right? This is our main. Paste it. Terraform provider. Who is our provider? AWS. If you have Google, this is another way. If you have Azure, this is another way. This is our configuration. Provider AWS. What's my region? I'm going to work in, most probably I'm going to work in AP South 1, I think so. Mumbai ka AP South 1 hai na? So how do we find it? I think AP South 1 na? Copy and paste it, right? So this is our resource. There is a two types, resource and data. If you come here resource, that means create. Data means get the value from the AWS as simple as it. Resource provides a VPC resource. It's going to create VPC. Before starting anything else, we are going to create some Amazon account here. Let's go AWS account. AWS Web Services. Go here, create an AWS account. You can say my account. Sign in, complete sign up. You are new, just click on the sign up. Fill out the details, right? And create a new AWS account. Click on this. Yeah, you need to create, type VPC, AWS account name, fill the whole ground. If you are not able to do it, it's on the YouTube, then come back. It's very simple step, it's not complicated. You need one credit card, I think so. You need one credit card powered by international, not Visa. Anything Mastercard or something else work. I don't think so Visa work. Just create one AWS account. After you create a AWS account, you will find this kind of UI over here, right? If you want any region, you can select it, but I am Indian, Mumbai is near me. Let's reduce the latency. So first I need to create one IAM users. What is IAM? What is IAM? Identity and Access Management. Like if you want to create multiple users for your single AWS account, you can come and create here. Just go to the users, click it here. I already created 2 users. I want to create new user. Just click on the create user. Let's say another username is Ram. Click on this. First go to the create the name of the users, custom password. I'm just typing something, type. No, I don't want to create. If you want to create password like at the time, you can create at the time of login first time. I don't want to create it, that's okay. Simply next step. Must not confirm the password you enter, at least 8 character, okay. Next. I don't want to save, never. If you are not able to find this group, directly go to here, place admin, get administrative access, it's going to be whole account. Next, administrator policy, create users. As simple as that. Download CSV, console sign in URL, RAM, show password. I don't want to show you guys. Download CSV. Anyway, I'm going to delete the user after the creation. This is my password. This is the CSV file. Username, this is one segment. This is one input. RAM. Password Pratik Sontakke @ console. This is also important. This is our console URL, right? I think this is the incognito account. Okay, RAM. Password. This is the password. Okay, what's our ID and alias? This is your ID. HTTP just after the this slash. Right? This is our ID and alias. You can check here as well. RAM. This is your ID. This is account ID normally. I am user. So yeah, that's how you can create IAM user. You must create it, okay? Don't use root ID and password, right? So yeah, just going to this one. Go to the Terraform now. So just create this file first. I am just going to test it. Just going to test it. Terraform apply. Before applying, I'm just going to Terraform init because we don't have Terraform. You know npm init. हम क्यों करते हैं npm init? To download dependent dependency in your local computer. That's why we same way we did Terraform init. Okay, ठीक है. Terraform, you can see Terraform initialize here. First Terraform. I'm not going to use this one. I'm going to, because there is one problem in my view. CD this one. CD 2 in your room. What is this? Okay. This terminal is very handy to me. I am using this terminal, Terminus, so-called Terminus in Linux. It's the paid one, so you can use any terminal, but I'm used to it. That's why I'm using it, right? It has free trials, I think so. Terraform apply. If you press Terraform apply and you have not configured your Terraform, right, with the AWS account, it will throw some error. Let me see. Just type Terraform apply, nah. Yeah. I have already configured it. If you saw like configure your AWS ID and credential, उसको सब कुछ दे दो उसको जो चाहिए, right? We don't need any chaos, right? Just give it. Now he said type yes to confirm it. He didn't ask me to configure my AWS account here because I already configured it. If you got just port the error to the ChatGPT, it will show you the answer, right? So he said apply complete. Resource 1 added, 0 changes and destroyed, 0 destroyed. So 1 added, right? What he added here? Right, just type VPC login to your user's account, just type VPC. You configured on the Terraform and you have login. So try to be in same account, right? Whatever you configured on your Terraform, login via console. This is called console. You can see console aws.com. This is called console, right? So you can came here and see. This is the VPC you created just now. Let me walk you through again. Just give it a name. So how do you know? How can you give the name to it, right? आपको कैसे पता लगेगा कि इसको name कैसे देना है भाई? So yeah, now I want to give name to my VPC, right? अभी हमें इसको नाम देना है तो another way you can ABC like that way, but we are using Terraform, not that way. Why we are using Terraform? I will explain in later stage of project, right? So I want to give it name. So how can I don't know anything. How can I give name? I'm going again and finding just this is my resource. Like I can AWS VPC. This is the resource. Same I am using here, and I am with name. So basic stack. This is name. I think so. Just try. This is the way you can put it. Name here. Name, right? So how can you apply it? Just press Terraform apply again. VPC refreshing the state and the value, yes, because I want to apply it. Modifying, right? What changes? One change. What one change we did? You can see I'm going to refresh it, right? Right here you can see main, right? This is a name. Where it come from? Here, bro, here. Let's say I want to give it. I'm going to give name project 01, right? Project 01. I'm just going to Terraform apply it. You can see one change. Basically, you have bought one land over here. Just type yes. One change added, right? How can you create VPC without Terraform? Click on the create VPC only. Name is like project 001 console because I'm clicking on the console. Range I can use. You can use the same range as well. It's nothing. Default create name, right? Tags के अंदर name you can like different tag. The same way we are using Terraform tags के अंदर name, right? Same name, right? Same, right? Yeah. Just removing the tags, creating okay. That's how you can create by the console. The both VPC are the same. This is created by the Terraform. This is created by the console. Main is how can you destroy it? Just go create action, delete VPC. Delete it. That's how you can console it. Delete it. This is my VPC. If I want to delete VPC from the console, how can I do it? Terraform. Command is destroy. Yes, it already showing you what he is going to destroy. This is our Terraform, and we are going to I see, yeah, one destroy, one to destroy. What is one to destroy? This resource. Destroy once is completed. Let's go and see. I'm just going to refresh it. Now we have, right, project 1 dev setup. In corporate, we don't even open the consoles most of the time. We use Terraform only. That's why we are using Terraform. Our main motto is to create a project of a production level, right? That's why we are using it. So what's our flow? What is VPC? Your isolated slice of AWS account, full control over IP addresses, subnet and routing, essential for security and organization. Now we need to create our subnet. To create subnet, first we need to have, what is VPC? A big LAN. What is subnet? A small portion of that LAN. So if you want a small portion of the LAN, first what you need to have, right? Now we are going to cut it out. So first we need to have VPC. We already created the VPC. Now we need to create subnet. How to create subnets, right? Just copy it and paste it. So subnet, copied and pasted. AWS subnet main. I'm just going to comment it out for a while. Came here, type Terraform apply. As soon as it's applied, I'm just going to one added. What's my Terraform ID? Come here. You can see VPC ID right here only. Just click on it. This is your VPC ID, right? There is no subnet. There is one routing table created by default when you try to create your first VPC. Not first, try to create any VPC. Default route table is always there. So this is my ID. We need to have VPC ID now. This is my VPC ID. Okay, now I am going to create one subnet. I am just going to, it's from the Terraform, and this is the our okay, one added, one changed. What changed? First, see, you don't have any subnet right here. Refresh it. Go back, come again. You will find one subnet, right? Automatically linked to the associate table. Default. By default, this is a default route table. Any subnet you have created without mentioning the route table association, it will definitely go into the default route table. Okay, confused? That's okay. Our main focus is how we create subnet, right? And your observation is that as soon as we create our first subnet, it automatically assigned a route table, right? Okay, that's our observation. Be with it. So if you want to subnet, this is our project. You can see resource map subnet. This is our subnet. Click here. Coming back to the tab. This is your land. This is called VPC. Where is VPC in your project? This is your main land. First you bought the main land, so you know the ID. Then you make a part of your main land. To make a part of your main land, you need this ID. So I put it. This is a one part. What's the name? First subnet. If I want to make multiple parts, let's say I want to make multiple parts, and I just type one for the one, second subnet from there, third subnet, fourth subnet. That's also work fine. And now we create first, second, third, fourth part. Just trying to apply. I am going to explain the error. How can you solve the error, right? Duplicate resource AWS subnet. How many AWS subnet? So we are not able to create multiple subnet, but I already told you can make multiple parts of your one VPC. The smallest part is called as subnet. So it's contractor statement, right? Showing an error. Error is line number 31. Okay. This is the error. AWS resource name main was already declared line number 123. Right? Line number 23 पे already declare. Okay, that's okay. You must be unique per each type. वो बोल रहा है कि resource name, this is your resource AWS subnet. What's your resource name? We type it subnet and we are going to type it one subnet. This is first subnet. By the way, this is second. So this is our resource name, subnet 1, this is subnet 2, this is subnet 3. You are not going to duplicate. हम duplicate resource name नहीं use कर सकते. If you want to use a resource name, it must be unique because resource is same. AWS subnet, AWS subnet, AWS subnet, AWS subnet. Because this is a resource type, we want to create AWS subnet. How many? 4. That's why we are going to subnet 1, subnet 2, subnet 3 and subnet 4. Now I am going to apply it because it's a unique. A name must start with a letter and underscore. May not only letter dash underscore and dashes. Must start with a letter and underscore. Number you can't start. It's naming, you need to follow naming convention as well here. Yes. So we have 4 subnet now. Subnet 1, 2, 3 and 4. Conflict with another subnet. Oh, what's the main problem here? CIDR block. I'm going to explain as we go further what is CIDR block. But just make it 1. Just change it to 2. 3. Understand, you can't learn everything at the same time. There's always a step, right? If you don't know anything about it, let's skip for it now. But I make sure I'm going to teach it as we go, right? So we learn 3 things. You can't use same name for the same resource, right? That's why we change the name, subnet 1, 2, 3. What's the naming convention? You can't use numbers at the starting of the name of our subnet. That's why we change it, sequence changes, subnet 1, subnet 2, subnet. Now 13, what we have learned, you can't use same range of CIDR blocks. That's why we are changing the range from 1, 2, 3, 4, right? Now I am going to apply it. If you read it carefully, they also told you the solution, right? Now oh sorry, yes, I missed it. Okay, 4 resource added, right? 4 resource added, 0 change, 0 destroyed. Let's go and check it. Go inside it. You can see now. So we had currently 1, 2, 3, 4 subnets, right? So that's all about subnet. I have one question for you guys. Let's say I destroyed the whole infrastructure now. Once I destroy the whole infrastructure, the VPC ID is gone now, right? We don't have this VPC ID now. Which one? A451. A451. I'm just going to show you. Can you see? Yes, I want to destroy all the things. Already showed 5 destroyed. 1 VPC and 4 subnet. 1 VPC and these the 4 subnet, right? Even the 5 resource. 5 destroyed successfully. And if you come back here, you will not able to find anything. VPC A51 does not exist. A51 does not exist, right? Gone. Let's say now I applied it. Does it show error? Yeah? Oh, I destroyed it. Nah, I need to apply it. Sorry. Because we have hard coded it here. ये हमने hard code करके रखा है, ठीक है? Just typing yes. What? Creating EC2 subnet operation error. EC2 create subnet HTTP response error code 400. You can say this one error. Invalid VPC ID. Okay, invalid VPC ID. I'll just refresh it. What's our new VPC ID? And this is our old, so I need to change it. ठीक है, now I'm going to apply it. Does it work now? Obviously it is going to work. Because our new VPC is this one. Project 1 Terraform and his ID is, उसकी ID ये वाली है ना. 0 subnet, right? Okay, let's go back. Now we have 4 subnet. So first you saw that AP South 1 में 2 थे, AP South B में 1A में 2 थे और 1B में 2 थे, right? Now it's randomly it's going to select, right? Till we specified it, okay? Now I am going to destroy it. It's going to destroy whole thing and when you are going here, just refresh it, everything is gone, right? So my question is that every time we destroying it, हर बार हम उसको destroy कर दें, हर बार हम उसको जब नया create करें, that time we get a new VPC ID, and we need our code be dynamic, right? For that, this is not feasible. I don't think so it's feasible. So what I'm doing, every time VPC is creating, right? So this is the AWS VPC, right? Dot, what's our VPC name? This one, example. What we need ID. That means these subnets are always dependent on our VPC, right? So I'm just going to change the VPC name as well. Every time it's going to create new VPC when we apply from the basic. Every time we need to configure this value, right? But now what I did, I just told that go to the VPC. Okay, AWS VPC resource, great. Then go inside this exact variable like resource VPC. This is your VPC, right? This is AWS resource. This is the name of the resource, VPC project 01 Terraform. And inside it, if you enter control and spacebar, you will find ID, right? Take the ID dynamically. Now every time you create it, okay, it's going to take dynamically now, right? We have destroyed it, right? We don't do anything. Now if I applied it, yes, what did it show? ID unknown after apply, right? Okay. 5 changes I did. I didn't got that error, right? That we got earlier, right? This error, VPC ID is not found. This time we didn't found it. That time we found it, right? Why? Because we use dynamic value. Whatever the value of this automatically assigned here. If you enter, you will be able to see it. Yeah, 1, 2, 3, 4 VPC. By default, it's connected to the route tables. Okay, that's all about VPC and subnets. You know how to create it. And what's the dependency between VPC ID and subnet? You need to specify the VPC ID into a subnet while creating the subnet. As simple as that, right? Okay, you bought a new land. Here, you convert it into 4 parts. 1, 2, 3, 4. And you also learn must be unique name for each subnet. Range is also unique. Now the main question is, this is VPC. VPC खरीदना था, VPC ले लिया हमने, right? Then we need to convert into 4 parts, so called subnet. 1, 2, 3, 4. We convert into 4 subnets, right? Now another one is IGW. Now we have to connect these 4 subnet, right? This guy, this guy, this guy, this guy, to the internet. Connected all 4 bedrooms to the outer world. Outer world is internet. As simple as that. Come here. AWS Internet Gateway. As simple as that. Internet Gateway. How are you going to create it? Pick up the example, bro. As simple as that. And if you want to read, you can read. VPC ID optional. If VPC ID is in, see the resource alternate way tags. You can see it. VPC ID. Simple. Come here. We are going gateway. We name it IGW. As simple as that. So what's our VPC? AWS VPC, bro. AWS, the front door allowing traffic between VPC and internet, only one needed per VPC. I said whole VPC only you need one IGW, internet gateway. So this is our VPC ID. This is our internet gateway. We have attached it through it, right? Let's apply Terraform. Let's go to the internet gateway in the console. Internet gateway. You see, he's only one. ID is 5C3. You can see the name, Devshak VPC. Oh, sorry. One I did. I'm just going to refresh it. You can see second VPC and it's attached. IGW VPC project 01 Terraform and it's attached to this VPC, right? DBC99 can go here and can DBC99 is our project and you have successfully attached it. Now you can see the result. Resource map, IGW, route table. If you saw a previous diagram, you don't able to see it. IGW VPC. Okay, great. That means all the 4 these guys are connected to this route table. One link is missing here, right? So it's our observation, right? Stay with it. That's all about IGW. Now we are moving to the NAT. We have 4 VPC. We have the land now. Okay, we had land now and we had 4 subnet. Now we connect all the 4 subnet to the we had one guy who is capable to connect the all 4 subnet to the internet. Who is that guy? IGW. Now we want to connect all 4 internally, that one first will talk with second, second with third, fourth, and vice versa. Anyway, for that we need to create routing table. Who is responsible for internal communication? Please remember, internal communication is NAT, external communication is IGW, Internet Gateway. Both are the gateways. Gateway is responsible for communication. AWS VPC Cloud, AWS NAT Gateway. How can you create it? Just copy the example, as simple as that. If you want to create public NAT, this is the way allocation EC example ID subnet. Okay. If you need to create a private NAT, you need to configure this private NAT. I'm just going to put mandatory fields here, right? I don't want to make it unnecessarily complicated. Okay, AWS, this one, for example, IGW, GW, AWS NAT Gateway. Connectivity type. If you don't mention is by default, it's connectivity type. Let's see. Optional, continuous, default to public. If you don't mention is, that means public. We are not going to mention it. What's the subnet ID? I don't want to mention this either. I'm going to associate with it. AWS subnet dot. So that's how we define AWS NAT Gateway for internal communication. Coming here, make sure you enable na. Sometimes it's not automatically saved by VS Code. Make sure you enable file autosave option, right? That's a tip from my side. Terraform apply. Let's see. I'm just going to the console first now. This is my console. You can see NAT Gateway. Just open it. We don't have any NAT Gateway till. Just type yes. Apply cancel. Do you want to perform this action? Why it's cancel, bro? Missing allocation ID is missing parameter. Okay, great. Allocation ID we need, right? Always we need the. What is EIP? Now you need to know what is EIP. We need this one, na? So just put there, na? AWS EIP example. This is from this one, na? So that is, this is from somewhere else, okay? ये भी तो कहीं से आए होगा. Just search. Yeah, it's just going to associate elastic IP to your network, so it can communicate. Before it, domain VPC. I need a name, bro. We have mentioned it. EAP. EAP.example.id. Okay, got it. Web IB instance. I don't have instance actually, na. Oh, sorry, I have copy pasted, but we don't have instance, right? It is going to work. मैंने पहले ही देख लिया था ना, यहाँ पे तो कुछ नहीं था NAT में ना. It's pending, right? You can see na, associate selected IP. This one, EIP VPC project 1 Terraform. Can you see it? Right, get from here only, bro. Internet Gateway, elastic IPs. You can go here and see it. EIP VPC, exact same, right? Today is the first hands-on, right? Just focus on how I done the things. In the same way, in company you also going to do it. It's not that you remember all things and go there and just like hacker somebody typing and infrastructure is up. Every day you struggle, every day you know something, you don't know something. Manipulate it, collect it, align it, create it. It's flip code, learn and repeat. Scan is over. Added 2 resource. Which resource? You can see here. This one. Another one is NAT. Successful. That means elastic IP, right? This is your elastic IP. This is the range of elastic IP. Going to VPC. Come here. Resource map. You can see one. Still, these are linked to the default route table. These are not connected to anything. You can see the graph. 1, 2, 3, 4 subnets are connected to default route table. When created it, it's a default route table. But we create IGW, Internet Gateway for the public access, NAT Gateway for the internal communication, right? We have observed that these two are not connected. Yeah, now I'm going to be showing you how can we attach this one. I'm going to complete this whole flow right now, right? Route table is responsible for flow inside your VPC. Now you come here and flow is blocked. Subnets are not connected to the IGW nor GW, right? Internet Gateway and NAT Gateway, okay? Come here, come to the route tables, come here, routes, edit routes, add routes. Whatever traffic comes to this route table, going to connect with internet. Save changes. What's CIDR block? 0, anything, any traffic. Now if you come here now and you reload it, you can see it actually now. Can see link. Before this link is not present, right? Now it's present, right? Internet gateway is connected to the route table. So now I am going to explain you EIP. EIP stands for elastic IP addresses. Why we are using EIP here? Because we want static IP for our EC2. What is EC2? EC2 is a virtual machine, right? And we want our virtual machine consistent. Their public IP must be consistent. I'm just going to show you demo now. Just launch new instance here. I'm just going to launch new instance. Name it like that's okay. I'm going to launch it. As soon as I launch it, you will see you got a new public IP here. This is not. This is our newly created EC2. This is called as virtual computer. We are using EC2 service. You can see here as well, right? So why we are initializing it? We just need to check. If you are not configured EIP in your AWS, that means your public IP must change every time you restart it, right? Just copy it. This is your first time initialized IPv4 public, right, address. I am just going to reboot it now. Okay, not reboot. I just going to stop it first. That means I'm going to restart it, right? Stop, then start. It's called as refresh. I'm just going to stop it. Yeah, it's stopping. Well, but so EIP stands for elastic IP. Elastic IP is directly proportional to static IP addresses. Like if you have configured your EIP, that means you got static IP for each EC2 instance. That means it is not going to change once you restart. You can see it stopped completely, right? You don't have IP4 address now. Now I'm going to start it again. Start instance. So what your earlier IP address? 132.3.3.95.195.90, right? Just wait. It's pending. It's in pending state. It's running, right? Okay. What's your new public IP for it? This one. Can you see the difference? Earlier one is 132.3.3. Another one is 132.0.187. So it's changed every time I initialize. I restart my computer. Is it good that just think about it, when you restart your computer, every time you restart it, your password will change. It's a lay example, but yeah, okay. That's not a good thing. That's why we assigned EIP. What is EIP do? What does EIP do? If you have already configured EIP, once you restart, your IP will be same like this only. It's a simple. What is EIP? It's static. It's allow EC to have static IPs. As simple as that. Okay. Static IPs means constant IP. Even you restart your EC2, it's not going to change its public IP address. Okay. Now I am going to move to the route table. Okay, I already explained what is route table. It's manage the flow inside your VPC. If you enter in your house, how can you tell where to go, how to go? So it's job of route table. Okay, so we are going to create it route table here now. AWS route table. What are the resources? How are you able to create it? It's all about route table. So this is syntax of route table. Just copying it. I'm just going to terminate my EC2 क्योंकि हमें इसका bill नहीं चाहिए. Everything you do under your VPC, you are responsible for it and you got charged for it. Terminated, yes, it's terminated. So now we have to configure it. I'm just going to name it. So what's my VPC ID? You need to provide your VPC ID. VPC ID. What is my VPC name? This is your VPC ID. Another one is AWS route table. I want it to be named as public. Now we need to define CIDR range for it. So what is block? Zero point zero point zero point zero. Why we are putting 0, 0, 0? It means all the things allotted here. Any IP can access this because it's public. So AWS Internet Gateway. This is now. Then what we need to know? We need to put a tag here. So it's a simple way to put tag here. I don't want this one currently. So what's your name? This is a public route table, right? Can we see, can we apply it, or we need something else? Let me show you now first. Put yes here, and if you go here now, under the VPC route table, we'll find our new only two right here. Let's say added resources added now. Just that this one you can see route table 000 IGW, this one. Where did you find it? Route table, public route table. Okay, public route table, that's okay. And if you go inside it, you will find nothing is associated with it. So now I am going to association for it. How can you write association for it? How can you write resource route table association subnet ID route ID? This is your associations. You can see it. How many subnet we had? 1, 2, 3, 4. So what I am going to do, I am going to create multiple associations. Just going to write 4 because I want to associate. That's all. Can we apply it? Yeah, let's go and see. First, I'm going to show you. Are you able to see any explicit subnet association? No, no. Apply it. No, what's the error? Already existed. Let me try it again. Okay, great. Then what's the error? Problem is that one subnet, you cannot associate it one subnet with two routing. One here, second here. Now I am just going to recreate the problem. Now we don't have association with any of the routes. Subnet association, nothing. Here you can see explicit subnet association, nothing. Nothing. Now I am going to initialize two subnets, 1 and 4. Now what's the problem? We associated two subnets. Now what we are doing here in our VS Code, this is why first subnet first and 4 are already associated with default routing table that we have not created by the VPC, right? Because it's automatically created when you're creating VPC. But we created our own route table. So what's happening? You cannot associate one subnet with two routing table. That's the problem. Then it's already associated with these, and you are going to associate these again with the newly created route table, public route table. 1 and 4 already associate with this default. I'm just typing default here, default route table, okay. And even trying to associate 2, 3 with public route table here, that's okay. That's perfectly okay. But what you are doing also, 1 and 4 also you try to associate with public route table. That's creating chaos here, right? So I'm just going to apply Terraform apply again. You can see it will throw automatically error, right? Why they are throwing the error? He said RT4 is already associated with, where is RT4? Already associated with this one. RT4 trying to associate 4th subnet with this route table. But this is not happening because it already associated with a default route table. This rule is you can associate only one subnet with one route table, okay? So what I am doing to solve this issue, I am just going to remove all the subnet from here, and you can see this is, we don't have explicit subnet associations. If you go here, you can see here anything, we already had two. Two is assigned. While applying 2, they created a problem. So we're trying Terraform apply, and it's now going to work fine. Yes, that's the solution for the problem. You can go and see VPC now linked correctly. Yeah, you can see here public route table and default route table both are connected to IGW, but default is not connected to any subnet anymore. Okay, so that's the correct way. Public route table, IGW protected, IGW. That means you can download anything from the outside world using public route table. That's why we name it public. Anyone can access it. You can get anything from the outside of your network. Okay, that's all about routing table. Now we are going to learn Terraform basics first, then moving forward, right? So Terraform start with this one, Terraform AWS, source is HashiCorp AWS. If you are GCP, you can find HashiCorp something like GCP, Azure. If you're Amazon, that's why we are talking about HashiCorp/AWS. Version is it's all about version 5.0, and this is our region. So what do you mean provider? Provider mean it's already decided by the AWS. So provider is AWS, region is AP South 1. Then we are moving to the resource. You can see here resource AWS VPC, resource AWS subnet, resource AWS subnet. So what do you mean resource? Resource mean actual AWS component you want to create on AWS. It's an actual AWS component, right? AWS subnet, that means you are going to create subnet on the AWS. AWS Internet Gateway means you are going to create AWS Internet Gateway, like Internet Gateway on AWS, as simple as that. EIP, that means you are going to create EIP, like Elastic IP on AWS. Actual resource of the AWS called as resource. It's a name, a resource name. It's basically it's nothing to do with AWS. It's only for us, like if you want to write ID. So how can you write AWS repos? This is our name. It's a name of the resource on local. So yeah, it's all about it. Another one is provider. So what is provider? Have you seen provider on our Terraform file? Here is the provider. Which provider we are using? Required provider AWS. You can see provider is AWS. The provider is AWS. We are using Terraform for the AWS. If you are using for GCP, you can find it on Google what's for the GCP. If you are using for Azure, you can find it for the Azure. Why we are using AWS? Because we are initializing our infrastructure on AWS. That's why we are using AWS. Okay. Then another one is variable. We haven't used variable yet. Let me show you how can we use variable. To use variable, you must create one file called variable.tf. So how can you define variable? You can define just by variable. What's the name of variable? Let's say by default, what's the default value of the region? So AP South 1. This is our default region. If you want to write description, you can write description as well. You can write like this. What's our region? This one. How are you going to use it? Just go here. Don't hard code it, right? How can you write it? Variable var.region. You can see var stands for variable.region. What's the default value? AP South 1. It's the default value. You have make it dynamic, right? If you change the variable from here, let's say you have used it 100 times in your code. Region equal to var region, var region, var region. That means you need to change region only here, right? If you change the value here, it's going to reflect all over your code, right? Just like a code in JS or Java, right? So yeah, that's called variable. Another one is state. So yeah, what is state? You can see this is called state, and it's a Terraform state. That's why we call this TF state. You can see on the screen, this is called Terraform state. So we have multiple commands, right? Terraform apply, Terraform destroy. So when we apply it, this state will change. It's a like database what's on AWS by Terraform. So once we apply Terraform apply, this state is going to change. So it's a database what we have rolled out on the AWS. If you do some random edit here, when you try to destroy it or apply it again, it will create a chaos because you don't have database. So how Terraform knows what we have applied or what we are going to apply or what we are going to edit, change and destroy? Because of that TF state. It's a state management in short. And we have multiple commands in Terraform. We are currently using apply and destroy. What apply do? Whatever changes we did here, it's going to reflect on our console. What destroy do? Whatever changes, whatever infrastructure we are initialize from this one, it's going to destroy it from the, like killing the EC2, killing the VPC, going to destroy it. There are two more commands like Terraform init. One more command, it's just like npm init. What is Terraform init? It's going to download dependency required for the Terraform. So then another one is Terraform plan. What is Terraform plan? You are going to plan your infrastructure before apply it. So I'm just going to show you what's Terraform it. First we are going to destroy Terraform. Destroy. If you're not using Terraform, then you have to go to the console and click each and every piece and delete it. Sometimes you forget, you don't have data. This is storage. It's kind of code, right? You can apply it multiple times. So we are waiting to destroy infrastructure. That's what the work of destroying the infrastructure. Let's say AWS stable public destruction. AWS Internet Gateway destroying. AWS Internet Gateway still destroying. What he had destroyed, you can see destroying. AWS subnet 3. So what destroy do? It destroy your infrastructure. And where did he know that what we have created and what not? ये जाता है TF state में और देखता है कि कौन कौन सी infrastructure we have rolled it out. Yeah, we have rolled out EC2 because we commanded as a destroyed. Once it destroyed, now this file changed. You can see it's 207, right? We are destroying it. Once it destroyed, this file automatically changed. You can see, yeah, you can see this is changing 81, 207 to 81, right? What is that showing? Yeah, we have destroyed the whole infrastructure now. Let's go. You can see 13 destroyed. Nothing is here. It's a live example. What it is storing? It is storing the database, like data, what we have rolled out or what we are going to destroy. Because we destroy, we don't need that anymore, right? First, what we did, Terraform apply directly. Another way is Terraform plan. We are going to plan our infrastructure first and get reviewed by our manager. Then if manager approve, there we are going to apply it. So how can you do that? Infrastructure plan out. Out is one flag. Wherever Terraform we can do is TF plan. Okay. So TF plan out. We are going to plan it. You can see we have created one file here itself. TF plan. You can see we have created Terraform apply. What we did here? We said Terraform plan out. That means your output will be stored in file name TF plan. Now what we are doing, Terraform apply. From which file? TF plan. That means whatever plan we have created here using this command, apply in your infrastructure. As simple as that. We have created this plan here. Now we are going to apply it. You can see now we are going to change TF state. This is only this one, na? Only 9 lines, right? As soon as I apply, we are applying the plan we have created using earlier command called as Terraform plan out. You can see. Okay, इसने क्या क्या अप्लाई कर दिया इसको सब कुछ पता है यहाँ पे. We applied 13 resources, 0 change, 0 destroyed. And if you go to that file, I already showed you it has only 9 lines. Now it has hundreds of lines, right? Because it's a data. Terraform knows this is the infrastructure we have applied. If you want to destroy it, you can take everything from here and try to destroy each and everything. You can see VPC ID is also stored here. You can check. Go to the AWS console. Go to the VPC, your VPC, refresh it. You will see the ID match. That's how it's going to destroy it. Now I am going to destroy it. How can you destroy? There are 2 ways to destroy it actually. Na? Earlier, how we are going to destroy? Terraform destroy, simple as that. So we are going to plan our destruction. Terraform plan hyphen destroy. It's a flag. Where we are going to store is out. TF plan underscore destroy. It will generate one file called Terraform destroy. TF plan hai na? So as yeah, here you can see one file is generated. If you want to apply destruction, now you can see TF state changes. I'm just going to destroy. You can apply. First you have planned the destruction in TF plan destroy file. Now we are going to apply that destruction. You can see here lines are getting wiped out. You can see. So we have destroyed 13 resources. So that's all about Terraform apply, Terraform destroy, Terraform plan, Terraform event. So that's the basic of Terraform. You don't need to know anything else. Just go with the flow. As you got stuck, you will learn. And if you stuck somewhere, you got new error, just chat GPT it. What's our plan now? Now we are making it this file production ready by using multiples, variables and stuff that we are going to use it. Okay. Now we are going to reformat it. First we are going to create Terraform. It's called as main. So what's main? This is the main file. Here you can see this is the main. Inside the main we usually stored our providers, this line. Now we are going to create one more file called network.tf. So inside network.tf we are going to store everything else except these two. Provider we are going to store it in main. Now let's see. Here you can see we have stored main. Main mein what's our provider, that is AWS. In network we are storing it. So we are providing standard name formation here. So how we are going to create it? So resource AWS VPC. What's our project? It's a main. It's our main. It's main. We call it as main. We are going to standardize it. What's our CIDR block? So we are going to define CIDR block inside a variable. So variable, it is VPC CIDR. We are just going to reformatting it. So what description? Another, what's the default value? What's the type of it? I already told you how we are going to use variable. Just type var CIDR block. Okay, now we are going to tag it. What's the name? We don't want here actually CIDR. We want here var CIDR block. So I want to store one variable called name of the project. Variable project name. What's the project name currently? AWS subnet. So that's the important part now. How many subnets we had? We had 4 subnets, na? So we are not going to give 1, 2, 3, 4. We had one feature here that's called count by Terraform. Count. We are going to provide 4 count. That's it. So it's going to initialize 4 times. As simple as that. VPC ID, I know it's a name. That's how you generate dynamics. What it's doing? It's a function inside a Terraform. By CIDR block. What's the value? This one. Plus 8 count index plus 1. That means what's his default value? This is his default value. No? This is his default value. What's here value? This is here value. For count 1. For count 2, 2, 3 and 4. So this is going to change it. I am just going to write it like this. For 1 count 1, second count 2, third count 3, fourth count 4, 1 count 1. So because we have count 4, it's a loop. It's run 4 times. So yeah, if it's going to run 4 times, we need to give name as well. Then we are going to put in which availability zone we are going to put our subnet. So availability zone. So you can see data availability zones available in index. How many available zone we had? We had 3 available zones. So randomly it's going to pick any available zone. What is availability zone? You can come here and see it. Are multiple isolated location in each region. AP South 1 is one region and there are multiple locations like AP region 1, 2, 3, 4, 5, 6. There are multiple. India, na? AP South 1, AZ 1, 2, 3 in India. AP South 2, we are inside AP South 1. So we have 3 regions. AZ1, AZ2, AZ3. Someone has 4 regions. Just look at 2. AP North is 2. AB 1, 2, 3, 4. But we only have 3 regions. That's the reason. Now this value is going to randomly pick up by the Terraform. And we need to have tag now. So what's our tag? I'm just going to var.environment. Environment we don't need it. Var.project public subnet data AWS availability zone available names count. We are doing it. What's our project name? This is our project name. Project 1. Public subnet. How many public subnet we are going to create it? 3 public subnet, 3 private one. Because we only have 3 availability zones. AZ1, AZ2, AZ3. That's when dynamic naming convention. AWS subnet, which is public. It's variable. AWS subnet. Now, how many subnet availability zone we had? That's the main question. So, for the count, we are going to initialize one variable called var AWS AZs. So, where we are going to define it? Number of availability zone to use type 3. Default is 3 because we already checked it. So yeah, count, it's going to run 3 times. Internet gateway, it's okay. IP example is okay. AWS NAT Gateway is okay. Routing table, we need to this also change. We need to change this as well. We are just refactoring the code, nothing else. We are just learning new thing. It's count one thing. Naming convention, you can chat GPT it. I already explained it. Public subnet, right? We need to have private as well. We need to have private subnet. That's why we are creating it another one is private, and we are just doing it like Other than, I don't think so we had any error. Just focus, here is 1, here is 101, because we don't want to confuse CIDR range. That's why we are making so different. What's the value here? Here is like 101, 102, 103, 104. That way. The default value is 10. /24, bro. /24. So availability zone, index count, it's private, it's all the thing the same. Tags also changed. Internet gateway, we are moving to the internet gateway. So we are just going to change the name here. Where project name IGW. What is NAT? Where is NAT? GW, where is NAT? Define NAT. We are going to define NAT here as well. I already explained what is NAT. What I do, I am going to just reformat it in front of you and explain at the end of how I am going to reformat it, okay? Because it's going to take a lot of time otherwise. So yeah, we are going to start it. I'm going to explain everything once again. So it's hardly going to take 20 minutes. It's a Terraform. Required provider is AWS. They are already explained. Source is HashiCorp AWS. Version is this one. You don't need explanation for it. It's okay. Provider AWS. AWS availability zone is available if then data source remains the same. Network TF. So it's a network.tf VPC. Okay, what's this CIDR? What is CIDR range? What's our CIDR range? You can go and see it here. 10.0.0.0/16. So how many IP is it going to provide it? 65,536, 65,000 around. I already commented here. Whenever see this code, you will understand better. Okay. So another one is AWS subnet. What we did earlier, AWS subnet. We have created 4 subnet earlier. Subnet 1, 2, 3, 4, right? Now what I am doing, I am just counting it. How many number of availability zone our Mumbai region has? 3. So it's going to create 3 public subnet and 3 private subnet. So count is 4. Count is just like for loop. What is for loop? For loop, let's say let I is equal to 0. I is less than 4. I plus plus. So 0, 1, 2, 3. 3 times this group is going to 1, 2, 3, right? The same way, how many availability zones we have? 3. So 3 public subnet will be created and 3 private subnet will be created. So CIDR, what is CIDR block? 10. This is our 10.0.0, right? What's our value? Where VPC CIDR? 10.0.0./16. What's the value of this one? Because we applied count. For first public subnet, value will be 1.0/24. For second subnet, all the same. Here is 2.01/24. For third, 3.01/24. We only had 3 availability zone. After that, it's not going to run. Its availability zone is going to pick random. Anywhere. Data.availability zones, available names, count is 1. It's a variable, you can see. So map public IP and launch. Enable auto assign public IP for the instance launch directly into a subnet. Useful for testing Bastion host, not strictly needed for the ALB. So this is not, we are currently using it, that's why we are skipping it. When we are going to use this feature, I am going to explain only at that time. Okay. Name. So it's a dynamic way of naming the subnets. What's our project name? This is our project name, right? Project 1. So project 1. So what's the name here? Project 1 public subnet. Data availability zone must be count.index. So for the first, it's the first one. Second is the second one. Third is the third one. For better understanding, I'm just going to apply it. Terraform plan. Out plan. First, we are going to plan it. Then I'm going to required by the Terraform it. Terraform plan. This is private subnet. The same way, it's going to create 3 private subnet. This I don't want currently. The naming convention is same, just private subnet is going to change it. I'm just going to apply it and then I'm going to explain. Another one is gateway. After public and private subnet, we had gateway. So what is internet gateway? Why we are using internet gateway? Project 001 VPC. And if you go here, route map, you can see here we had subnet one public and one private in each region. We have 3 regions. How he decided to put each subnet, one subnet in every region? How? Because here availability zone 1 first subnet, because we know we have 3 availability zone, and you can see here you can go basically and subnet. We have 3 regions, 1A, 1B, 1C. We have 3 availability zone, 1A, 1B and 1C, and each one has its own public subnet. Here then we are going to create one internet gateway. So what's the name of internet gateway? Project 01 IGW. You can see here itself, Project 1 IGW. Okay. For NAT we need to create one EAP, elastic API. So I already explained why we need to create EAP, to get static addresses. So where to find EAP? Here, elastic IP. We'll find here Project 1 NAT EAP. You can see Project 1 from the variable NAT EAP. Okay, Terraform true. So this is just a metadata kind of thing. AWS iNetWay allocation ID is this one. We just have created it, and subnet ID. Okay, we are going to place in public subnet. Always remember, when we are going to create NAT gateway, you need to place it out in public subnet. You say we are using NAT for the, I already showed you, this is your LAN, this is your public subnet 1, 2, and this is your private subnet 3, 4. Okay, I already told you NAT is for the private network. NAT is a private network in short. But always remember, we need to configure NAT inside the public subnet to work it better. That's the main crack here. That's why we are using public subnet here. You can see public 0. That means what is public? AWS public.0, any first subnet from the public 1A, right? Its ID, its his ID, and depend on AWS internet gateway. It's depend on internet gateway. For what NAT is doing, NAT is providing inside our private network. So for getting access, अगर आपको NAT को access देना है internet का, you must create a NAT in your public subnet, and public subnet must have internet gateway. Now I am going to explain chronology, that is most important. First rule is, if you are creating NAT gateway, you need to place it in public subnet, and public subnet must have internet gateway. NAT is responsible for providing internet to private subnet. That means providing internet inside a private subnet, and IGW is providing internet to the public subnet. So what's the chronology? You must put NAT inside the public subnet, and public subnet must attach to the IGW. If this chronology is completed, that time only you are able to access internet inside your private subnet. Got it or not? Once again, you have NAT. Why we are initializing NAT? We need internet access inside our private subnet. That means private network. Without NAT, private network don't have access to the public internet. So for that we are creating NAT, where we are creating NAT inside a public subnet. And public subnet also must attach to IGW, internet gateway. What's the feature of internet gateway? To provide internet. Simple. And if this chronology is completed, NAT placed in public subnet and public subnet connected to IGW, only that time we are able to access our internet inside private network. The feature of NAT is, this man, if he has NAT power, he can able to call anyone outside the world, but these people are not able to call it. Not understand? Let me explain it again. What's the feature of NAT? Let's say this is me and I had NAT power, and these guys are you. I can call you anytime, anywhere in this world, but you can't call me back. That means if EC2, like virtual computer, has NAT, that means it can download any software from anywhere in the world, because it's open. He can download it. Like these are the another server, he can download anything from anywhere, anything anywhere from the any server. But if this servant wants some file from this guy or some data from this guy, they are not able to access it. But these guys had power, he has special permission, he can get anything from any server, from any public server. But public servers cannot get inside the private subnet. That's mota it is. That's why we placed our our NAT gateway inside a public subnet. You can see here, where is the subnet? It's public subnet. Another one is route table. Route table mein we need to associate some values. Where is route table? This is our route table. This is your public route table, this is your private route table. Now I am going to show you difference. That's the important thing. Routing. So you can see on a public, first we are going to see public route table. What I already told you. First this flow, NAT, where we need to place NAT inside public subnet. And public subnet must attach to IGW. So what I am doing, this is a work of public route table. Okay. So what public route table is doing? Remember 0.0.0.0/0. That means any IP from the world, anyone from the world can enter it. It's include all world IP. This IP means is include all world IP. Can get inside it, like can connect it to the IGW. That means any IP inside a public route table are able to access IGW, Internet Gateway. That means it global internet. Any IP inside public network can access public internet. Got it? And this one is for the local. Any IP range between 10.0/16 are able to access our local network. So that's all about route table. I am going to explain it again as we go further. I know it's a blurry picture currently. Once the project is completed, you know why we are doing certain things in certain way. That's okay. It take time. It's honestly take time. Where this is coming from, where this association is coming, I'm just going to explain it now. So if you can see, EIP is attached to the NAT here only, and public route table is public. So this you can see 0.0.0 AWS Internet Gateway. So if you go to the public, you can see 0.0.0 are connected to the IGW. So it's coming from here, and name of it public route table. You can see project one public route table. Great. So what is the association? How many AZs we have? 3 AZs. Where we are defined it here. This is the value. This is the value. This is the value. Okay. So 3 AZ. That means this resource run 3 times. The first time it run count index 1.id. Subnet public. You can see this is public, right? Public. Then what's it's count 0. It's also going to run 3 times. It's going to run 3 times. 0, 1 index, routing table to this one. Association route table. That means you can see associate route table. This is our subnet public AP 1A, 1B, 1C. All the public subnets are associated with the public route. That means any one come inside the public network can communicate to this one, this kind of subnets. Everyone present inside this room. I'm just going to explain with a layman language currently. So if you get confused, let's say we have this 2 region. This is public and this is private. This is public and this is private. So public has 3 region. Okay, 1, 2 and 3. 1, 2 and 3. So what I'm telling you, associate subnet, that means, and this has one route table. This is one route table. And these route table are able to access internet. Okay, this is the internet. So all 3 are able to access internet. So association means this is the route table. Anybody came inside a public subnet are able to access the internet. As simple as that, because we had associated multiple IDs here. Going to the private network. What do you mean private network? What I already showed you. You need to place your NAT inside any public subnet, any one of public subnet. So I just prefer first one. You can prefer NAT. Here is our NAT, and this is our private subnet 1, 2, 3. I'm just going to rename it private for the A, B, C. This is our 3 private subnet. So anyone inside a private subnet A, B, C. First go to the NAT. NAT here, NAT is present here, and this subnet has public access. So indirectly NAT is able to access publicly. Every service inside private subnet can access internet, but internet cannot access that service. That guy has NAT power. He can call anyone, but none of them call him reversely, right? So that's called NAT. And association subnet is private subnet A, B, C. Where we have associated, you can go to the private route table. You can see associations here. It's private route table, private association, count A. Because we have created 3 private subnets, so we are associating it. Yeah, that's all about our network fundamental today. So I already show you demo here, and if you want detailed demo, you can see here as well. Click on your VPC, you can see, I can explain you the map. You have AP South 1. I am just clicking on a public subnet. It's connected to Internet Gateway, as I already explained you, and it's connected to the all public subnet. Because it's a public route table. What's the flow? Public route table. Public route table is connected to public subnet and connected to Internet Gateway. What's a private net? Private flow. Private route table connected to the private subnet. Always you need to connect it to private subnet. That's why we are connected to 3 private subnet. Private subnet AP South 1A, 1B and 1C. Okay, and it's connected to the route table. And the route table is connected to NAT gateway, and NAT gateway is placed inside our public subnet. So that's why it had access to the internet. So any service inside a public subnet cannot access service inside a private subnet. That means what I am explaining you currently, what this flow means. This is your land. You created 2 subnet. For each subnet you created 1 route table. let's say this is a public and this is a private and this is the world. So यहाँ पे जो भी लोग प्रेजेंट है इन पब्लिक सबनेट, ये लोग बाहर वाले बंदे से बात भी कर सकते हैं और बाहर वाले बंदे भी अंदर वाले बंदों से बात कर सकते हैं. इट्स बोथ वे कम्युनिकेशन. बट लेकिन यहाँ पे जो बंदे प्रेजेंट है, ये वाले बंदे बाहर वाले लोगों से तो बात कर सकते हैं, बट बाहर वाले लोगों को अंदर वाले लोगों से बात करना मना है. ये बंदा इससे तो बात कर सकता है, बट ये बंदा इससे बात नहीं कर सकता, बिकॉज ये सेम फैमिली से बिलोंग करते हैं. दे आर कजन्स, राइट. सो ये दोनों आपस में एक दूसरे से बात कर सकते हैं. ये कभी भी याद रखना. मतलब पब्लिक राउट टेबल के लोग प्राइवेट राउट टेबल के साथ में बात कर सकते हैं. एंड टू वे कम्युनिकेशन, जस्ट लाइक जो पब्लिक वाले लोग बाहर वाले इंटरनेट से बोथ वे कम्युनिकेशन करते हैं ना, द सेम वे पब्लिक और प्राइवेट में भी बोथ इंटरनली यू कैन कम्युनिकेट इन द बोथ वे, दिस वे एंड दिस वे. बट ये बंदा बाहर वाले से बात कर सकता है, बट बाहर वाला बंदा इससे बात नहीं कर सकता. बट ये दोनों नेटवर्क के बंदे एक दूसरे से इंटरनल कम्युनिकेशन कर सकते हैं. सो या दैट्स ऑल अबाउट नेटवर्किंग फंडामेंटल. So I already showed you what is associating route tables. Explicitly connect each subnet in correct route table. You can see explicitly connect each subnet. Public के साथ public route table को connect कर दिया, private को private के साथ connect कर दिया. Okay, then demo plan. Demo I also showed you. This is the demo in short. Open the terminal project review. Yes, okay. Verification. That's okay. Verification also done. This is the verification only. Capturing useful info output. I am going to explain in another lecture. Recap and next. What we are going to next? What we have built today: VPC, public private into 3 availability zone using count variable, IGW internet gateway, NAT gateway, EIP elastic IP, route tables, associations that I already explained everything. Learn core AWS networking. What's networking? In short, if you need to create network, what's your first approach? You need to see how many subnets I need to create. Oh, I bought a one LAN called VPC. I need to divide it into 4 subnet, and 2 subnet is public, 2 subnet is private. Why need public subnet? Both way communication. Why need private subnet? One way communication. One way communication means internal people can talk to the outer world, but outer world cannot talk to the internal people. Both way communication means handshake. Both people can talk with each other. But always remember, public subnet people can talk with the private subnet people, and private subnet people can talk with the public subnet people. Both way communication is possible internally. And always remember, NAT gateway always plays inside a public subnet, because public subnet has access to the internet. That's why NAT gateway also able to access the internet. NAT gateway is able to access internet, so private people access internet via NAT, so indirectly they will able to access the internet. So yeah, next part 2 is provisioning your database, managing secrets. In next lecture we are going to learn our output values and data layer, RDS, secret, data management, end of tier provider. We are going to learn this in next lecture. And before quitting this lecture, make sure you destroy infrastructure. Terraform. Make sure before quitting this video you destroy infrastructure. I'm just going to destroy it. And it's take time. Also verify. Once you destroyed it now, also verify from here. Main is, if VPC is deleted, that means your main LAN is erased. That means nothing else. Everything is inside main LAN. So always remember, when you destroy your whole cloud infrastructure, just check your VPC. Say it is available. It's taking time. Yeah, 18 destroyed, 18 resources destroyed. I'm just going to refresh it. Yeah, it's destroyed. Okay. Yeah, that's all about it. If you found this lecture helpful, just drop a comment below. And if you have any doubt, you can ask me in the comment section, and share it with your friends who is learning cloud, and give me feedback what I need to improve. And yeah, that's all about it. We'll see you in the next lecture. Bye bye.